Well, good morning, everyone. We're going to get started here in just a minute. It looks like we got three people on the line already. Hope everybody's having a wonderful Tuesday morning. I know that if you're in the Panhandle and I'm actually in Alabama, we're preparing for a hurricane. So we're gonna do our thing today. It's not supposed to get here until Thursday, so hopefully it won't interrupt Thursday's training. Today we're going to talk about basic oven repair. Okay, I'm gonna just talk about generalizations. I'm not looking to try to make it so that you're able to repair every single oven at any time, but I do want it so that you can have some knowledge and know all about oven repair. Okay, so let's start right with our thanks to Encompass. Thank you, Encompass, for providing this training. I hope that everybody here gets a lot out of it. Like I said, this is basic, so I just wanted to let you know about that. It is basic. Okay. So thank you, Encompass. I'm going to stay right there. If you go to that YouTube page, that will take you to Reggie Williams's YouTube. And you can get some good information out of Reggie's YouTube. So let's just go ahead and dive right in. Okay, if I'm going to have to work on an oven, the first thing that I know is I need to know the meter basics. Okay, so a meter is designed for really three things. Okay, it is designed for resistance, voltage, and current flow. Okay. Why is a meter may be called this is why a meter may be called a multimeter, because you're checking all three. You have the ability to check all three. Okay. You can get anything from an analog meter to a digital meter to an amp probe, all of those. Okay. I have an amp probe, and I keep a multimeter in my truck. Because I never know what I'm going to need. So I always keep a multimeter in my truck. And it's not even digital. It's an old analog multimeter. As a matter of fact, let's see if I've got another one laying right here. Okay. No, I don't. I thought I had it, but I don't. So that is just your basic meter. Okay. We're gonna go through some of them. They perform multiple functions and measure the different kinds of voltage, whether it's AC or DC. In other words, AC is alternating current, DC is direct current. Okay, if we're talking about examples of resistance, the opposition to current flow, a component has measured in a space, and it's called ohms. Okay, the electrical value components or devices have a resistance value. The symbol for the ohms is basically the horseshoe is the easiest thing to tell you about. Okay, so some of the examples of things that you could measure resistance with: your inductor, your circuit board, your power supply, your resistor, or a diode. If I'm going to do a check on a diode, I may have to have a 9-volt battery. So I always keep a spare in with my multimeter. That way, if I need it, I've got it, and I don't have to go back out to the truck and try to find one. Okay, voltage. What is voltage? It's the electrical component or potential differences between 2 points measured in units called volts. symbol for voltage is just the V, okay? The potential can either be DC, which is direct current, or AC, which is alternating current. We've already talked about that, okay? DC voltage source, and an example is a car battery, okay? An AC voltage is the line current that comes into your house. Okay, what is current? Current is the flow of electricity through a conductor, okay, at a certain rate based on the voltage source provided and the resistance to the flow of the current in the circuit. Current is measured in amperes or amps. The symbol for that is the capital A. Just like voltage, current can be AC alternating current or DC direct current based on the voltage source. Okay, you need to know all of this information so that one thing about an oven, you've got to have a meter. You need to be, whenever you have an oven issue, you've got to have a meter. You can't just walk in and guess at it. Please don't. I have seen a couple of people that actually did not, and they just they're parts changers. They're not a technician. Okay, there's a big difference between a technician and a parts changer. So don't be a parts changer. Okay, an example is a light bulb. A light bulb in the room of your home. When you put the light switch to the on position, you are connecting the current path, and which that goes through the 120 volt fuse box, through the switch to the light bulb, and then back to the fuse box ground. Okay, this circuit contains alternating current. Talking about your light bulb in your home. Okay, so my meter's role is, as identified above, it is critical to remove the operating power source from the unit being diagnosed. The most common method is to unplug the unit from the wall outlet or turning off the appliance's power at the circuit breaker box. Okay, so if I'm going to do anything except read voltage, I don't want power to it. Okay, because what's going to happen is, if I don't take and disconnect the power, I will actually either shock myself or I can blow my meter up. So measuring resistance, okay. If you look right here, it shows you exactly the resistance. What I'm going to do, I need to know the resistance, okay. Once the power is removed, you can turn the meter to the ohms function, and the meter's internal backup to check a component. Okay, so if you look right here, this is set to the second highest ohms resistance scale. So you need to know how many ohms you're going to be doing. So you actually need a wiring schematic. One of the things that you really need is a wiring schematic if I'm going to be working on an oven. If I have an oven, or if I have just a range, I'm going to really need a wiring schematic. Okay, so this is what typically you find today in a range. Okay, if you notice, there's an L1 connector, there's a neutral in the center, and then there's an L2 on the right. Okay, on the very bottom there is an earth ground. Okay, so the next thing we're going to do is talk about a little bit about an earth ground. What is an earth ground? Okay, but if I'm going to check power to my unit, that's the first thing I want to check, is to know if I've got power to my unit. So I've got to either go to the plug and check my power in the plug, or I can go right back here to where it is connected into the unit itself, and I would go between, like I said, L1 on the left, neutral is in the center, L2 is on the right, and then there's the earth ground that's in the just underneath it. Okay, you do not connect an earth ground to the neutral wire. That is incorrect. Okay, it tells you whenever you go to connect things, that's how you know where the earth ground is. Okay, I have an example of an earth ground. Okay, what is an earth ground? By definition, an earth ground is exactly what it says. Okay, it's a ground. It's a physical ground connected to the earth via conductive material such as copper, aluminum, or some kind of aluminum alloy. Okay, as previously mentioned, the earth ground is physically tied to the chassis, which in turn is connected to the earth ground within the power cord, and it finally connected to the earth via the three or four prong outlet. Okay, it's got to be a 4-prong. It's not a 3-prong. If you have a 3-prong, you do not have an earth ground. Okay, so we're going to talk about an earth ground now. What does an earth ground actually look like? Okay, this is what it looks like whenever you go to the pole. This is outside with how this is in the pole off of the electrical pole itself. Okay, so this is the earth ground to the power pole outside. If I have an earth ground, I may also have a earth ground right next to my box. Okay, that where my power comes into the house. It's usually if you like. I used to have a really good friend that worked for the electric company, and he had one of the earth grounds that he had to use, and it was about a 6-foot solid copper, about 3/4 of an inch, not 3/4, about 3/8 of an inch, and it's driven down into the ground. Whenever it's driven down into the ground, there's a wire that comes out of your box, and it goes to this grounding wire. It ties into that grounding wire with a clip that screws in to marry the two together. Okay, so 3rd prong physically connected to the earth ground. That's it right there. Okay, in my house in Daytona, I don't have a plug like this. My plugs are 2-pronged because my house is built in the 40s, so I didn't have an earth ground, and so I don't have the earth ground into the box. So this is something that I don't have. So you're gonna need to know that whenever you go in to start to check things. Okay, here's an example of it with an earth ground. Okay, here's an example of it without an earth ground. Okay, if you notice, this is a thick black colored cord. The gray cord is usually just a 3-prong plug. This is what I have on my house in Daytona. I just have this 3-prong plug. So that's your basic difference between a earth ground and no earth ground. Okay, we're going to stop right there. And does anybody have any questions so far? Answer, if you have a question, put it down in the comment section and then hit enter, and I will be able to see it. Okay, if there's no questions, we're going to go ahead and move along. Okay, so if you know me you know that this would make me cringe. Okay, so my question is, what's the matter with this picture? Okay, what is this technician doing that is just a super bad no-no? Okay, so the answer is he's not using any flooring protection. Okay, you have got to use flooring protection. If you look at his has a tile floor. Okay, if I don't use that on my tile floor, I'm gonna chip, scratch. It's gonna be not good, and it's always the customer that's always already on your back, wanting to watch over everything that you do. Okay, if you damage something, please just let the customer know. But the one thing that I will tell you is you have got to use flooring protection. We have, if you know me, like I said, you know that's one of my things that I insist on. Whenever I was a service manager, if I caught you doing what this guy did, the first time it was a warning. The second time you were let go for a day. At the third time, if it ever happened a third time, and I actually had a technician that I had to let go because he ended up having 2 claims filed against my insurance. One of them was for about $5,000 because of the scratches that he put on a customer's range floor. So please take the initiative to use flooring protection. This is not a good picture, but if you look right there, you can see where they the flooring protection goes right up under the wheel. So what do I have to do? I have to push back on the front of the stove, slide that up, slide that little. It's about probably about 12 to 14 inches. Slide that up under the legs, and then I set it back down. Then I can pull the unit out, and I don't have to worry about scratching the floor. Okay. So we're going to keep rolling. So what am I going to do? As I come into the house, okay, I ask the customer as I'm walking to the back, what's the matter? What's she experiencing with her oven? Okay. And they're going to tell you something, and you need to listen to the customer, see what she has to say, and then you just go in and verify. Okay. So if I walk in and the customer's complaining my bake element doesn't work, okay. So what am I going to check first? The first thing I'm going to do is to make sure that I have 220 volts, at least 220 volts coming to the oven. Okay. So sometimes it may be less to 208, but it needs to be in the 200s. Okay. How do I check that? Okay. I go from L1 to neutral. Then I go from L2 to neutral. That actually will give me 110 both ways on both sides. If I go to, if I want 220 volts, I go from L1 to L2. If I go from L1 to L2 and I have 100 volts, I got a problem somewhere else. And I'm checking this at the plug. I am not checking this on the unit. If I've got that 220 volts at the plug, I'm going to plug it back in. Okay. Whenever I do that, I'm going to remove the plate that I just showed you. I'm going to go back to that. Okay. I'm going to remove the plate. Look. I'm going to remove the plate so that it exposes this terminal block. Okay. And then I'm going to go from L1, which is the black wire. And then I'm going to go to L2, which is the red wire. I'm going to go across those two with my multimeter turned on 220, and I should see what I should be reading 220 volts. Now, if you have a good multimeter and it's got my good multimeter here, is a digital multimeter, okay, and it's got basically. Make sure I hadn't turned it off, or make sure I turned it off. But it basically, all I do with this multimeter is turn it on. Okay, it'll read how many volts it has if I'm checking volts, or I can set it to amps. It'll check my amps. It will check my resistance. So I can do all that with the multimeter that I have. But like I said, I'm going to go from the black to the white. Okay, that gives me 110. Then I'm going to go from the red to the white. That gives me another 110. Then I'm going to go between the two, and I get the black to the red. That still should give me 220 volts. Okay. So L1 to L2 should read 220 volts. Check between L1 and the neutral, you should get 110. And then if I go to the other side, just like I said, I'll check between the L2, which is the red, and the white neutral. Okay. What's wrong? What is a wiring diagram? Okay. If I don't know what a wiring diagram is, I don't need to be working on a appliance. Okay. You got to know how to read a wiring diagram. I have covered this in a basic wiring diagram course, and then we updated and did a step 2 wiring diagram course. You can go back, and if you go back to Encompass University, like I said, there's basic wiring diagrams, and then the step 2 is the upgraded diagram. Okay. A wiring diagram is a visual representation of the physical connections and the physical layout of an electrical circuit. It shows the electrical wires, the components, where the components are interconnected, and can also show where the components are connected in the system. Okay. So you got to have a wiring diagram. Whenever I'm going out, we're going to cover that a little farther on down. You're going to have to pardon me because this morning I got up and tried to log in at 7 o'clock because I usually come a little early for you guys, which is I'm in Central Time, so it'd be 8 o'clock Eastern Standard Time. So I try to do that so I can get all my presentations done, and I had to redo my presentation totally. That's the reason we're on the format that we're on. For some reason, my format didn't work. Okay. So there's a huge difference between gas and electric. Okay. Gas is a 110. Okay. And an electric is a 220 outlet. All right. So if I have a gas bake element, we're gonna go and we're gonna try to find out what the issue is with a gas bake element, why it's not working. Okay. Here's a hidden bake element that is for your electric. And then right here is the non-hidden bake elements. So that's the 3 types of elements that you're going to experience as a technician. Okay. This is a broiler element. And then you have the same thing with the broiler element for electric. It's just going to be 220 volts. Okay. So the top 5, said that wrong. The top 5 reasons that my gas oven won't light. Okay. The on-off lever on the gas valve could be tripped off. The igniter could not be pulling over 3 volts. I'm sorry, 3 amps. The safety valve switch could be bad. It could be your infinite switch is bad. Last is a thermal fuse. Not all ovens have a thermal fuse. Okay. Some of the more expensive ovens will have a thermal fuse. Usually this is whenever it has a self-clean, because we need something so that if something happens and the unit gets stuck in the if the unit gets stuck whenever you turn on self-clean, the thermal fuse will stop all problems if it doesn't cycle properly. Okay. So here's an example of the on-off lever that I was talking about. So this not every single oven has these, but you need to be aware. I had a technician call me the other day and say, "Hey, I'm on a gas oven and it doesn't light." And we went through the basic things, and I checked and he checked. He was like, I'm getting my my glow bar is got 3.6 amps on it, but I'm still not getting gas. Is it my switch? And I go, I don't know. Could be your switch. You have to figure that out. This is something that you will never get gas if that on-off lever is turned off in the on position, is turned to the off position. Okay, so if I have a glow bar, which is what I call these, an igniter. If I have a glow bar, I'm going to look for the obvious things. Usually, I can see a glow bar if it's bad. If I turn it on and I get nothing to it, I'm going to immediately take out one screw, drop it down, and look at the glow bar itself. And this is what I'm going to look for. I'm going to look for a break in the glow bar itself, so that it won't allow the gas valve to open. This is a safety feature. Okay, so I've got to look for the obvious, which is this. Okay. Okay, so I'm going to check the amp draw. It should be about 3.2 ohms. If you get three, it depends on the unit. You really need to check the wiring schematic. On the wiring schematic, it'll tell you how many ohms you should be reading. So you need to know that information just to make sure that you don't have a bad glow bar. Sometimes I have gone out in my history. I have gone out. The glow bar was fine, but it just wasn't pulling enough amps. I'm sorry, it wasn't pulling enough ohms, and that was my problem. So I had to change it out. Okay. So one of the other things that I need to do on a gas oven is I need to check for continuity through the valve. If I don't have this continuity, it's not ever going to light. Okay. So what do? I go to the ohm scale. Okay. I put one lead on the terminal and the other lead on the other terminal. Okay. The red terminal, black terminal. You can see right here where it's talking about. If the valve shows a resistance of 0 up to 0.5 ohms of resistance, the valve is good. Okay. If I have an electric oven, okay, I'm going to check and make sure that it's good. Most of the time, if I have an electric oven, I know that oven is bad before I even start, because I can do a physical inspection of the cowl rod right here and see that the cowl rod is either broken or it's something's dropped on it. A lot of times what will happen is somebody will put something in the oven. They don't put a tray underneath it with that oven, with that bake element on. Somebody doesn't put a tray under what they're cooking, and it will come over and go over the top and end up shorting out that bake element. But that's something is a physical thing that I can look for. And if I see the cowl rod's broken, I know that it's not going to heat. I still am going to have to check it. Okay. But I know that I'm at least going to have to replace that cowl rod. So what am I going to do? I'm going to go between the L1 and the L2 off the switch. And I'm going to make sure that I have an L1 and an L2. Okay. 220 volts off of this switch. If I have a bad switch, because it can take out the bake element, and it can cause it to short. So you got to be able to check both of them. So if I think that I've got a bad element, I'm just going to check it this way. I'm going to go between L1 and LT on this cowl rod heater. Okay. And I'm going to look for 220 volts. Okay. Set your meter to the highest ohms scale. You should read between 30 and 100 ohms. Okay. If it doesn't need to be replaced, if it doesn't, you need to replace. If it doesn't read that information, then you need to replace the element. This is a picture of one, and you don't see, if you look at this at the very top right of that picture, you can tell that that's kind of drooped down a little bit. That ended up that the cowl rod was bad. So we did not get our ohms resistance through that. So we had to replace the broil element in this one. Okay. If you don't have voltage between L1 and L2, and I have a thermal fuse, I need to check my thermal fuse. Okay. Like I said, if I have an oven or a range that has a thermal fuse, these are usually what your problem is because it's set for depends on what unit you have. It could be set for about 900 degrees, could be 1200 degrees, depends on the brand. So you need to know that information also whenever you're going through, because if I need to see that I have continuity between this thermal fuse. Most thermal fuses are not resettable. Okay, Whirlpool made one that reset after about 20 minutes. It would reset. Sometimes it was 30 minutes. But if the customer says, "Hey, it doesn't, my elements don't heat," then I'm gonna be checking for the thermal fuse. If I go between broil, okay, and then the fuse there, I should read 220. If I don't, I'm going to go back to the fuse and I'm going and check both sides of that fuse. I'm going to check the ohms on it. If it doesn't ohm out, I'm going to have to replace that thermal fuse. If you have an oven, a double oven, a single oven, that's the first. It has a self clean cycle, I'm definitely going to go right there and check that first thing. All right. So here's an example of a thermal fuse in an electric oven. Okay. You can see where it goes to the back of the terminal block. And then you go to the switches, to the oven controls. You look at here on the left, if you look at the terminal block, and then you look on just past that, there's a circle where the thermal fuse is. Like I said, if that thermal fuse is bad, you're not going to read anything through the bake or the broil element. You won't read but 110. You won't get your 220. Okay. So I'm going to start right there real quick. Does anybody have any questions so far? I'm sorry, I'm still drinking my coffee. Okay. Looks like we do not have any questions. So we're going to go ahead and keep rolling along. Okay. So once again, I have, if I look right here at this wiring schematic, I have the thermal fuse coming off my terminal block. Okay. It's at the top right there. Okay. So I've got to know all of this whenever I go into, whenever I'm trying to check things. Here's an example of an oven, the gas oven. So you can see right here, where's my thermal fuse? Coming off the block right here. Thermal fuse. You can see it right here on about the middle far left. It says thermal. Okay. So guys, this was, like I said, this was your basic course. I just wanted to make sure that with it being oven season right here at us, I wanted to make sure that we had a basic course. We do have a couple of courses coming up that are dive into a specific oven or range. And there's one coming up for an Electrolux, which is the oven that I have the range that I have in my house. And then we have several others. I think there's one for GE, and they have one for LG and one for Samsung. So stay tuned. Those are coming up. I wanted a basic course just so that I could see that everybody at least had an opportunity to understand a little bit more about this unit. Does anybody have any questions? And I'm sorry, it's almost it's already up to about 82 here, so it's really hot. Okay. Anybody have any questions? Going once? Going twice? Okay, I'm going to give you the rest of your day. Thank you so very much. If you have any questions, my number is scrolling across the bottom of the screen. You can, if you text me at that number, I will get right back with you. There's my Mitch Williams 62 at Gmail. You can send me an email. That's either, and then there's Reggie's information. So please don't hesitate. If you have any questions, don't hesitate to call me. Reggie has had a couple of technicians call me because Reggie didn't know the answer and sent them to me, and we sat down and tried to diagnose it. So I have no problems trying to help you if you're having a really bad problem. The only thing that I ask is, if make sure, number one, that you got a meter, because that's one of the things that I'm going to ask is, do you have your meter with you? I need you to set it on the ohm scale. I need you to go to this position, wherever it is, and I need you to tell me what the ohms are. Or it may be that I want to check voltage. So I may ask you to check voltage. Okay. I just want you to be prepared. Don't just I don't know it, and so I'm gonna throw parts at it. Let's be technicians and not parts changers. Okay. Everybody had a wonderful day. Thank you again. I appreciate all your attention, and everybody have a wonderful day. Thanks again.